So our group name is Trailblazer. So we came up with a project called Navigating and Mapping by using Dijkstra algorithm. Uh, the problem statement is about uh, design and implementation of a real-time navigation and mapping system utilizing graph data structure. The system must dynamically update routes based on live traffic and guiding users away from congested paths. And by implementing Dijkstra algorithm to calculate optimal routes efficiently and optimize for large scale recalculate routes for divisional and closures. So now objectives are algorithm optimization. It uses to develop efficient graph structure and implement extra algorithm for real-time calculation on large-scale maps. And then real-time traffic integration. Integrate live traffic data to dynamically adjust routes, avoiding congestion and closures for optimal travel. Then user interface and experience. To design an interface for easy destination input, clear route visualization, and real-time traffic information, enhancing user experience, and testing and evaluation. Test system accuracy and performance under various conditions, identifying areas for improvement and optimization. Then now my teammate Jahnavi will continue with literature review.
So coming to the literature review, we have 4 points in that. First, coming to the graph representation, it will work on road network in the mapping apps as a directed graph, and each road segment is an edge and intersections are nodes. And now shortest path algorithms. Dijkstra's algorithm uses to find shortest path, considering factors like distance, travel, time, and user preferences. Real-time traffic updates. It is basically data. It will collect the data from the GPS, smartphones, and sensors integrated into the graph, and real-time Dijkstra's algorithm enroutes user around traffic. Turn-by-turn navigation. A graph based on algorithms use it for step-by-step directions, and it calculates and updates the route as the user progresses. And next, next slide. The mapping applications utilize graphs where nodes represent intersections and edges, depict roads, accurately modeling road networks. Google Maps employs directed graphs with edge data like distance and traffic conditions. Shortest path algorithm Dijkstra's to determine optimal routes considering factors such as distance, train travel, and traffic congestion. Turn-by-turn instructions are generated by using graphs-based algorithms, considering importing nodes and edges. Real-time data like roads closures is integrated for accurate and adaptive navigation. And supposed to work. This is basically divided into 5 types. And first one, graph algorithm optimization. It developed enhanced algorithms for route planning that consider additional forces beyond distance, such as real-time traffic conditions, user preferences, and road quality. This may involve improving existing algorithms or creating new ones. Real-time traffic integration. Investigative methods for collecting and processing real-time traffic data from various sources such as GPS devices, traffic sensors, and user-integrated data. User-centric navigation. Enhance turn-by-turn navigation by incorporating user-specific preferences such as avoiding toll roads, scenic routes, or specific landmarks. Develop algorithms that provide more personalized and user-centric navigation instructions. Scalability and performance. Address issues related to the scalability of graph-based algorithms. Optimize data structures and algorithms to handle the complex road networks efficiently. And coming to the last point, user interface and experience, it will improve the user interface of the mapping application to effectively communicative, and the advantages of the proposed enhancements ensure the application remains user friendly and easy to navigate. Next, my teammate Keerthana will continue.
So,
Uh,
okay, the next slide is
So
Workflow.
this is workflow, and then this is main application design, and this is architecture diagram. Then we go to the class diagram. This is class diagram. Then this is use case diagram. So now Kirtana will explain about the source code.
So,
okay. The source code, this code runs on a C program that implements Dijkstra algorithm to find the shortest path distance between the cities in the network. It allows user to input data about the cities and the distance between them, displays the adjacent matrix of the city to find and display the shortest path between two cities. And the step-by-step explanation of the code is first the global variable and the structure. The code begins with declaring the global variable and defining two structures. First one is struct node represents the node in the min heap, and struct min heap represents min heap data structure. The global variable like file read, adjacent matrix is exist declared to store the information about the cities and distance and path calculations. The second one is min-heap functions. The code provides functions to work with min-heap, which is the fundamental data structure of Dijkstra algorithm. The like functions in min-heap are initialize min-heap, swap min-heap, parent of min-heap, get min-heap elements from nodes, etc. Then second comes about the read input data. This function initializes adjacent matrix and the existent list. It prompts the user to input the number of edges and users to give the information about how many edges to be included and the names of two cities to be connected. And then the function show adjacent matrix is being provided, which displays the adjacent matrix of the city network. It checks if the data has been read or not, and the user to give the data first. And after the user is giving the data, it iterates to the matrix and displays the cities with their distance. Then comes the show menu and get choice. This function presents the menu to the user and asks them to choose from the following options. Like first is read data, then show adjacency, find the shortest path, and then fourth one is exit. This function validates the user choice and returns again. And the next one about the code is print path. This recursive function is used to print the path from the source from the city and the destination. And comes to the main function. This main function serves as the entry point of the program. It initializes the is file flag to connect the program loop. It continuously presents the menu to the users to call the appropriate function based on their choice. The loop continues until the user choose the exit to the program. And at last, the code combines the data structure and Dijkstra algorithm, and it's a user-friendly command line interface to allow the users to input the city data and find the shortest path between two cities and view the network information. So it is a practical example of applying data structure and the algorithms to solve the real world problems. So now we'll get to know about the advantages of the Dijkstra algorithms. So the first advantage is optimality. Optimality Optimality means the Dijkstra algorithm guarantees finding the shortest path from a source code to all the nodes in a weighted graph. Uh, this property is crucial where finding the most efficient route is essential for minimizing the fuel consumption, traveling, etc. And the second advantage here is versatility. This algorithm can be this Dijkstra algorithm can be applied to various types of networks, including road networks, computer networks, social networks. This versatility makes it valuable for different applications like GPS navigation, network system protocols, etc. The next advantages will be carried out by Jahnavi.
Uh,
Abhishitha.
Sorry, Abhishitha.
yeah. So 1 minute. The next advantage is about the real-time updates. So uh, this feature shows about when the road conditions are changed. It gives the update, like it gives the real-time update for in the app. And then the next one is ease of implementation by using Dijkstra algorithm. This simplicity makes it an attractive choice for the users to efficiently in terms of development of time. I mean, yeah, the next Jahnavi will continue with
Um,
another advantages.
the memory efficiency. And the memory efficiency maintains a periodic queue for efficient node exploitation, and it focuses on the most promising parts first and then enhancing memory efficiency. And coming to the compatibility with heuristics, it can be extended or combined with heuristics, and it improves performance in scenarios with factors like time travel. Now let us discuss about the disadvantages of Dijkstra's algorithm. And um, no heuristic condition. It's basically like greedy algorithm based slowly on current costs, and it wants to implement large consideration for heuristic information leading to suboptimal paths. And coming to the inefficiency with navigative edge weights, it assumes small navigative edge weights, and it may produce incorrect results in the presence of navigative weights. And the Bellman-Ford algorithm may be more suitable for such cases. And
The next disadvantages are computational complexity. Dijkstra algorithm has time complexity of O of V plus C log V, where V is the vertices and E is the number of edges. This can become a limitation in where large scale maps or networks loading to increase the computational time and resource requirements. The fourth disadvantage is memory usage. The algorithm requires storing and updating information about the distance from the source to the each of the graph. In dense graph, the network with large number of nodes results in highest memory usage. So next by Abhishekta.
So another disadvantage about this is it is not suitable for real-time dynamic network. So this Dijkstra algorithm is designed for static graphs. In dynamic networks where edge weights or connectivity can change in real time, and recalculating the entire shortest path of three can be expensive. And another disadvantages about this uh, project is limited to a single source, and this Dijkstra algorithm is designed for finding the shortest path from a single source to all other nodes. So in scenarios where paths from multiple source need to be considered simultaneously, the algorithm would need to be applied separately for each source. So now we conclude this project by telling mapping and navigation applications heavily rely on graph algorithm and data structures to provide efficient real-time and user customized routes and navigation instruction. By representing the road network as a graph, these conditions and guide users uh, through road network. The continuous integration of real-time data and user preferences ensures that these systems offer a reliable and personalized navigation experience, helping users save time and reach their destination safely. And now we'll run the code and we'll present it.
You see the
Kirtana?
exit now. Yeah,
Yeah, stop.
just a minute.
Can you see the screen?
Yeah.
Then, uh,
Yeah, programize. Yeah.
uh,
So again, the
one
menu is showing. So one, the read data, number of edges is
and A2,
A to B is 5,
then
and then S to G is 10,
S2J is 10,
B to B is 15,
A2 is 15,
B to S is 5,
B2S is 5,
B to D is 17,
B2D is 17,
X to K is 16,
X2K is 16,
K to S is 27,
K2S is 27,
L to D is 4,
L2D is 4,
Z to O is 2,
Z2O is 2,
G to Z is 56.
J2Z is
56.
56.
So the
Data is
demo
read
has been read
successfully.
successfully. So now I'm going to show the adjacent matrix. So 2 is the choice. So the
This is the adjacent
adjacent matrix.
matrix.
Yeah. So now we're going to
Then
find the
you'll
shortest path from A to G. So the option should be 3. First one you should enter
source
A,
vertex
just A,
A
then enter.
of
Now G.
G. Yeah,
So this is the
this is the
shortest path of,
shortest path.
yeah, from A to G. This is the shortest path. And to exit the program, we are going to
We
put
just
4. Exit. Yeah, goodbye. So this is about the program. This is about project we'll be doing. That is the navigation and mapping with the Dijkstra
map.
algorithm. So and using the data structure things. Thank you.
Uh, this is Abhishitha, roll number R33.
Keerthana roll number 2023.
Jahnavi, roll number 2040.
Thank you. Done right.